In this video, let us use matrices to solve systems of linear equations. We will also see how to use matrices in our graphing calculator to solve systems of linear equations. So we are going to use the reduced row echelon form. The reduced row echelon form is defined in a matrix where each row consists entirely of zeros, is below any row having at least one non-zero element. The leftmost non-zero element in each row will be 1. All other elements in the column containing the leftmost one of the given rows are zeros. The leftmost one in any row is to the right of the leftmost one in the row above. So this is the definition for reduced row echelon form. We are going to use this reduced row echelon form, which is explained by Gauss reduction formula, to find the solutions of systems of linear equation. First, we will take systems with 2 unknowns, and then we may extend that to 3 unknowns. Let's take the system 3x minus 4y equal to 7 and 2x plus 5y equal to -2. We have 3 important matrices here: the coefficient matrix, the constant matrix, and the augmented matrix. In the augmented matrix, we are combining the coefficient matrix and the constant matrix. So, in order to solve this, you consider the augmented matrix, enter that in a graphing calculator. Under matrix edit, it is a 2 row, 3 columns, and we won't have that line there when we enter. We get like this. So we can select matrix math and then search for the reduced row echelon form. The reduced echelon form will give you the coefficient matrix as a unit matrix, and then the answer is 3, -2. So in order to solve the system, we take the augmented matrix, enter that in a graphing calculator, and then take the reduced row echelon form, and the answer will be x1 is 3 and x2 is -2. Now if you want to solve the system using that reduced row echelon form, which is nothing but Gauss-Jordan's elimination, for 3 unknowns, again we use the augmented matrix including the constant matrix and the coefficient matrix, and find the reduced row echelon form of it. And here the coefficient matrix is a unit matrix, and then the constant are 2, 0, -1. So it looks like 1x1 is 2, and 1x2 is 0, and 1x3 is -1. So the values of x1, x2, x3 are obtained, and you can easily get the solution for this system using Gauss-Jordan elimination. Again, we have a system of equation three variables, x1, x2, x3. We enter that in a graphing calculator. We take the reduced row echelon form, but it looks like we don't have a unit matrix in the constant matrix. When I expand that first row, I get 1x1 minus 2x2 is 0. For the second row, it is 1x3 is 0. And for the third one, 0 equal to 1, which is not true. When this is not true, then this system will not have a solution. So the last row here is not possible, and hence you can say that the system has no solution. If the last row produces a contradiction, 0 equal to 1 is a contradiction, there is no solution to the system. Let us take another example of 3 equations here, and the augmented matrix is taken. The reduced row echelon form is this. So the first equation is x1 plus x3 equal to -3, and x2 minus 2x3 equal to 4, and the last one is true. 0 equal to 0 is true. So by taking a parameter for x3, the last unknown x3 as t, we can find the value for x1, x2, x3 like this. By plugging in x3 equal to t, we get x1 as negative t minus 3, x2 as 2t plus 4, and x3 is 3t. So by changing the values of t, we get infinite number of values. We get many solutions to this. So when the last row is 0 here, when there is no contradiction, when it is true, the system is dependent and it has infinitely many solutions. Now here we have got an equation in terms of 5 variables, but only 3 equations are given. When we take the reduced row echelon form, we get like this. So when we expand through the first row, second row and the third row, we get 1x1 minus 2x3 minus 3x5 is 7. 1x2 plus 3x3 plus 2x5 equal to negative 3. x4 minus 2x5 equal to 0. So the last case, x4 minus 2x5. So if I am taking x5 as t, x4 will be 2t. And again, I do not have x3 here. So x3, if I am taking another variable s, then I can get the value for x1, x2 in terms of this s and t. So by changing these values of s and t, you get infinite number of solutions for the system. So this has got many solutions to this. Now let us try to do this problem. A company that rents small moving trucks wants to purchase 25 trucks with a capacity of 28,000 cubic feet. 3 different types of trucks are available. 10-foot truck capacity is 350, 14-foot truck capacity is 700, 24-foot truck capacity is 1,400. If you are taking x1 to be the number of 10-foot trucks, x2 for 14 and x3 for 24, the total is 25 trucks. So the sum of this x1 plus x2 plus x3 is 25. 350 x1, 700 x2, 1,400 x3 will be the total amount 28,000. So we have the 2 equations, first using the number of trucks and the second one using the total capacity. So we can solve this augmented matrix, and the reduced row echelon form is this. So you get x1 minus 2x3 equal to negative 30 and x2 plus 3x3 equal to 55. We have 3 unknowns and we have got only 2 equations here. So by treating x3 as some constant, some variable t, you can find the value for x1, x2 in terms of t. So you have got infinite number of solutions to this. So if you are particular about few of the results here, maybe we can prepare a chart. So in this, 2t minus 30 must be greater than or equal to 0 because each one must be positive. So t must be greater than or equal to 15. And in the second case, it must be less than 18. So since it lies between 15 to 18, you can have values t as 15, 16, 17 and 18. Plugging in this result in those 3, we get a chart, a table like this. For 15, you will have 0x1 and 10, 14 foot truck and 15, 20 foot truck, etc. So this video helped us to understand how to solve systems of linear equations using matrices. Hope this video was helpful. Thank you for listening and thank you for watching.